Oh, don't.
Okay, so logic, we did a bunch of stuff with sets. Okay, so this one says let O equal the odd numbers from 0 to 15. So 1, 3, 5, 7, 9, 11, 13, and 15. E would be even numbers. So 0, 2, 4, 6. And set T is numbers that are divisible by 3. So 0, 3, 6, 9, 12, and 15. It's divisible by 3, right? Because if you do 0 divided by 3, you get a not decimal, right? You get 0. Yeah. Okay, so we listed each set. Are the sets disjoint? So what does disjoint mean to you? That they would have nothing overlapping. O and E are disjoint. There would be no overlap in that. So disjoint on a Venn diagram, that's disjoint. There's no overlap in them, right? List, O and T. So list means squiggly bracket. What numbers do you see that would be in both O and T? 3, 9, and 15, right? O and T, they both have a 3, a 9, and a 15. What does it do when you put a N in front of this? Just the number. So how many items are in E and T? So E and T both have a 0. They both have a 6. And they both have a 12. So then you write 3, because that's how many items. I don't want the list this time. Okay, so then we have math credits in grade 12. M is all math, P pre-calc, A applied, E essentials. List the subsets. So a subset is that you belong under the umbrella of something. So you could do this. Pre-calc is a subset of math. Subset. Applied is a subset of math, and essentials is a subset of math. Okay, 25 students. All students must participate in extracurricular sport or music. So we have sports, music, the universe. "18 sports, 17 are music." So I have 35 people. Well, that doesn't make sense because there was only 25 kids to start. So then what? Minus means that is your overlap. So now the 18 that play sports, there's your 18 that play sports. Okay, so let's do a pause. What do we want on our cheat sheet so far? I don't know. Do you like things like this? A and B? A or B? How would you do something like this? Not A. How would you do something like this? Not A or B. So what do? You look at A or B, so you already have that diagram, and then you do the not of that diagram, the opposite of that diagram. Did you make a note for yourself about when you do something like this is when you list so this is asking for a list and this is asking for the number of items. And then this is saying to list the items. Do we need the word disjoint on your paper? I don't know. Disjoint. There'd be no overlap. I don't know if you just want an example. Essentials is a subset of math. Do you want this example on there? Do you understand the overlap part? I don't know. If you want that example, write something like that. So if you want just a super simple example, 25 students, 18 do that, 17 do that, 35 means 10 overlap. Okay, let's try some more here. Maybe we'll find some more stuff to write. So this one says for an elective credit, the students have to pick between an art, a business, or a history. So I'm going to draw a Venn diagram situation. So I read on your exam, when I was looking at the grading marking scale, you have to have the box with the universe on the outside of your circles, or else they deduct points. Okay, where do you start when you read all these? Which one would be the good one to start on? One student takes all 3 courses. So you should put a 1 in the middle. Then you should go to some kind of and, so we could do the bottom one. 4 take art and history. Art, history, overlap, kind of a football shape. There needs to be 4 in that football. Did you put a 3 there then? Because you already had 1 in that football. So now there's 4 in that football. Top one, do you want to do that one next? An and. History and business is 5. So then that would be a 4. And then the 3 art business. 3 in art and business, so then that would be a 2. "16 students take history." That's where you go to next. So the whole entire history bubble needs to be 16. You so far have a 4, a 1, and a 3, so you have 8 in there. So then I need 8 more. So 23 take art or history. Art or history. So that entire thing needs to add up to 23. So what's already in there? 18. I've already highlighted 18. So now we need 5 more. And for the last one, I'm going to go back to this top. They had to choose. So there is no one on the outside. There's no one that will be on the outskirts. They have to have one of them. And there's 36 students. So now we just count. What's left? Did you pick 13? So the final question was, how many students are taking only one subject? So this person, this, these are the people that are only taking one class. There's no overlap with those. So that would be Okay, number 5. Languages, Spanish, Chinese, English. So this is the number of objects in English and Chinese. So how many people would speak English and Chinese? So this and this. So there would be 21 people that can speak both languages. Okay, this is not the same as kind of how we did it before. It's a different type of question. We don't just say 2. There's not 2 objects in there. I want to know how many people. How many people? How many people speak Chinese or Spanish or Chinese? So can you visualize that? That's anybody in these top circles. So I'm basically gonna do all that. Do you get 66? How many people don't speak English? So what I'm going to do is I'm going to cover the English one. So they can't be anywhere inside an English. And then anything else you see that's not the English bubble. So that is 10, 11, 12, 13, 14, 15, 16 people. We forgot to put this on our cheat sheet. This means how many speak Spanish but not Chinese. So you're in the Spanish bubble. So you're in the Spanish bubble, but you're not allowed to be in that bubble. So what am I looking at? I'm looking at anything in the Spanish bubble, but can't touch the circle that's the Chinese language. That kind of makes sense? So 40. So I'm going to jump back to my cheat sheet. So that's what it would look like. You're in A, but you're not allowed to be in B. Okay, last Venn diagram here. Okay, so this means we're going to be listing. This one we're just going to be doing some kind of number, list. On this one we're going to be making a number. So we're going to, when you see the squiggly brackets list, we're going to be writing people's names. This means you can be, so B or V or T, not that. So what would it look like if you, the or statement, there's 3 ors. If you could be in this, or this, or this, you could be anywhere in the circle. So then I don't want that. So who is that going to be? Jack and Lily. What did I do with the question here? I copied and pasted the question. I don't even know what this question is supposed to be. languages you can speak, cyberbully. I don't know what I was doing. Do you think this is getting bullied and then by your teacher?
Like the bully and then the victim. Why is someone's name Frog?
Who? Frog?
Teachers are cyberbullies.
Maybe somebody's name is Frog. I am pretty confident I would have copied and pasted this from somewhere, and I don't even know what I did. I don't even know where I came up with this. Anyway, whatever. It's the process. Okay, you can be inside T, all the things that are in T, but not in the B bubble. So this is the T, but you're not allowed to touch the B bubble. So in this bubble, but you're not allowed to touch the B bubble, leaves me with Carrie and Jean. The number of people that are not in V. So what I'm going to do, I'm going to cover V up. I'm not allowed to be inside V. And then just count how many I have left. 7. Lily's over here too, right? Don't forget her. 1, 2, 3. Frog's in this one. What did I say? 7? How many people are in the overlap of B and T? Or what? Or who's in there? Frog and Bob, right? Somebody might, yeah, have that name, Frog. Okay, ooh, this one's a hard one. I'm going to highlight this one. B or V. So B or V okay, B or V, got that? But you're not allowed to be in T. So I'm going to, you can't be in that. So who's left in my highlighted zone? 1, 2, 3, 4, 5, 6 names are left. 6 people. So I highlighted all the or, but then I was not allowed to be in that. Okay? We're going to do okay with Venn diagrams? I'm sure there'll be a Venn somewhere.
Wait, Marcy, you can't do the people
No, because you have to be in B or V. So that's why I started with the highlighted and then eliminated. Okay, let's go to our cheat sheet. Are we doing just a truth table? Okay, let's do the ands. Right, and, or. If you have something true and something true, you are true. If you say something true and something false, false. If you say something false and true, False. Okay, you want me to do an example? I'm going to say something false and then something true. A triangle has 4 sides and a square has 4 sides. That's false. That's what I just did. A triangle has 5 sides and a square has 5 sides. False. Or statements. If you say something true or something true, true. Something true or something false, true. A triangle has 3 sides and a square, a triangle has 3 sides or a square has 3 sides, true. Something has 3 sides, yeah. This one is true then. For an or statement to be true, you have to at least see one of them. That's true. For an and statement to true, they both have to be true. So if you say something false or false, false. True implies true is true. So I think we always talked about promising you'll be home for curfew and then missing your curfew. False. Saying that you'll probably not be home for curfew, but then you are home for curfew. That's okay. Saying you're not going to be home for curfew and then you're not home for curfew. Okay. Conditional. If, then. Inverse. Remember what that was? Not. Converse. What did you do with a converse? Flip-flop order. Contrapositive. Contrapositive. That long word means you do both. So you're flipping and negating. So biconditional has to read both ways. So, for example, is this biconditional true? If I live in Altona, then I live in Manitoba. Is the biconditional true? No, because the original statement is true. If I live in Altona, then I live in Manitoba. That's true, but if you reverse it, if I live in Manitoba, then I live in Altona. That's not true. So that is not a biconditional. Okay, so write the inverse of this statement. So now you have it on your cheat sheet. Inverse. And then you look on your cheat sheet, so you're not. If a bird has wings, so you're looking for if a bird does not have wings, then a bird cannot. Did you pick A? Just not. Contrapositive. So I'm looking for a negative and a switch. So I want the balloon will not float upwards first. The balloon will not float upwards. Not helium at the end. Converse, so that's just the switch. So today is Sunday, needs to read first. What is true about this statement? If a bird has wings, then the bird can fly. The converse and inverse are true. So the converse would read, if a bird can fly, then it has wings. The inverse would be not. If a bird does not have wings, then it cannot. Are there any birds that don't have wings?
No, but some birds can't fly.
I know. I don't even like this statement. You know, scrap this question because this whole like penguin deal is gonna throw us off. Okay. Okay. Let's do one more Venn diagram. There's going to be Venn diagram, I mean, somewhere, I'm guessing, on this exam. Okay, public transportation, drove themselves or biked, cycled. Okay, 164 people used all of the methods. "27 people drove and cycled only." So this is different because this has the word only in it. So you just write 27, drove and cycled. So you just write 27 because drove and cycled only. So now those people can't be in the public. Okay, before we subtracted, but because the word only is in there, different. Can you finish the next two above it then? They have these words only on them. Okay, Caius, you guys have the P. Jana's row, you have the D. Meadows row, you have the C. Artemis, your row has the outside when we're done our numbers. Okay, far row, did you get a P? Jaden, you look like you're ready for a D number?
572.
572. So this row over here, you can already type in those four numbers, add it together. Caius, Rego, or Alon, do you have anything for P? what is it? 785. Okay, add that on. And Meadowcate, Selena, do you guys have something for the cycled? 329. Okay, you guys have added all that up. How close are we to
94.
94. So the last row added everything up, and then we weren't quite at 3,000, so then you subtract. So putting them on the outside. Okay, so then there was kind of this logic puzzles thing. Let's say this is a Sudoku. So I need, in this box, I still need a 1, 2, I need a 3, and what else is missing? 8. So this box is missing a 1, a 3, and an 8. Do you have some spots where you would put them? The 1 can't go on the top. There's there. The 1 can't go on the bottom because of that one. So 1 is in the middle of it. 8 can't go there. So then that's the 3, then that's the 8. Okay, then I would jump over to this position because there's only one more left to go. Which is a 6. And you can do this box next because there's only one thing left across there, which is a 4. Only one thing left to go in the whole box. 7. Then you can jump down to the bottom. Okay, when you get to the center portion, this is what you should do. You should do your all ones. So if I'm going to put the 1, I say 1 can't go there, 1 can't go in the middle, so 1 is on the bottom, but then there's already a 1 there and a 1 there, so 1. That's what I'm doing. Cross-checking the 1s. Then I go to the 2s. So the 2 has to be in the middle row, and then column 1 is out, column 2, so there. Okay, and then just go through all the 3s like that. Let's go to number 16. So on this one where you're trying to figure out who does the what, who likes the what, this is what you should do. Put their names down the side. So there's all the people. Akila, Barbara, Kathy, and Donna go to the same high school. One likes history the best. One likes math. One likes computer science, and one likes English. So then you go through and read something. Akila and Kathy eat lunch with the person who likes computer science. So Akila does not like computer and Kathy does not like computer. Donna likes history the best. So Donna likes history the most. So then XXX, which leaves me with Barbara liking computer science. And that's all I had to solve for. Who likes computer science? Barbara. But you might have to figure it all out, so just that kind of strategy, right? Okay, 17, if you're going to put the numbers 2, 3, 4, 5, 6, 7, and 8 in, how are we going to even it out so that this and this are going to be the same? What do those all add up to, actually? $35 is the whole sum. Okay. I cannot put an even number at the bottom of this. Why can't I? So for instance, if I put a 2 at the bottom, it would leave me with 33. Can I split 33 up on 2 arms? No. So don't put a 2 at the bottom. Don't put a 4 or a 6 or an 8. So I'm either putting a 3 at the bottom, a 5 at the bottom, or a 7 at the bottom. So if I put a 3 at the bottom, that leaves me with 32. So I'd have to pick something to add to 1616. Or if I did a 5 at the bottom, I'd have 30 left, which means each arm would be 15. Okay, so maybe that can narrow it down for you. Oh, I put a 1 in mine. That's why I'm getting all wonky. I found one to work with the 5. I feel like the center should probably be the best one to pick, and then trying to even out the wings. Okay, but just some stuff to think about how to go about that. Okay, let's jump back to 15 here. We have a set of 10 cards. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We take those and we put 2 of them in each envelope. The sum of the cards is in each envelope. So then we have to figure out what did you put in what. Okay, so what do you want to do here? So in 3, we could have had a 0 plus 3, or we could have had a 1 plus 2. Those were the only options, right? In the 15, what kind of cards could we put there? We could have done 6 plus 9 or 7 plus 8. Five could have been 0, 5, 1, 4, 2, 3. Why can I eliminate putting a 2 plus a 3 in there? I can eliminate that. That's not allowed. Why? Because if you put a 2 and a 3 in there, you have no combos left for that or that, right? So that's for sure out. What's next? Should we try 13, 4, 9, 5, 8, or 6, 7? There's an elimination on that one though. Which one can you eliminate already?
5, 8, and 6, 7.
Can't do 6, 7 because it wrecks all your options for that. And why can't I do 5, 8? Where does it wreck?
Never mind.
Did you see something that I'm not seeing? Okay, 9. 0, 9, 1, 8, 2, 7, 3, 6, 4, 5. I can't do 4, 5, I know that, because it wrecks all my 13 options. Now where do we start? Would you try just one of these and then see where it goes? Trial and error? Okay, so let's start with 3, and which one do you want to pick? And then if it doesn't work, then we obviously go back. So if we pick 0, 3, let's pretend we picked that one to start. So then this would have to be the 1, 4. Then to 13, the 4 is already used up, so we would have to do 5, 8. Then we could go to 15. We've used an 8, so we'd have to do 6, 9. Does it leave us with a good pair? Yeah, 2, 7, right? And we did it. I wonder if the other way would have worked. Did anybody try it the other way? If I did a 1, 2, then I would have had to do the 0, 5. And the 13, I would have had to do the 4, 9. Then I would have had to do the 7, 8. Yep, that one would have worked too, actually. said name 2 possible pairs in the 5 and the 13. So we didn't even have to do that. That was just the answer. The 2 pairs you could have done the 0, 5, 1, 4, or that. But that was good. We went through and eliminated, right? That's why we eliminated those ones, because it would have wrecked all of our options for the other things, right?